Lesson: Algorithmic Transparency and Explainability Risks. Algorithmic transparency and explainability are critical components in the realm of AI model development, particularly as these technologies become increasingly integral to decision-making processes in various sectors. The risks associated with a lack of transparency and explainability can lead to unintended consequences, such as biased outcomes, lack of accountability, and erosion of trust. Addressing these risks requires a deep understanding of the frameworks and tools available to enhance transparency and explainability in AI systems. Algorithmic transparency refers to the clarity with which the operations of an algorithm can be understood and followed. It is imperative for stakeholders, including developers, users, and regulators, to comprehend how algorithms reach their conclusions. Explainability, on the other hand, is closely linked but distinct. It involves making the rationale behind an algorithm's decision interpretable to humans. This is especially crucial in sectors where decisions affect human lives, such as healthcare, finance, and criminal justice. One of the challenges in this area is the inherent complexity of many AI models, particularly deep learning models, which function as black boxes. These models can provide high accuracy, but often do so without offering insight into their decision-making processes. To tackle this, professionals can adopt several actionable strategies and utilize practical tools to enhance algorithmic transparency and explainability. A fundamental approach is to incorporate model interpretability during the design phase of AI development. This can be achieved through the use of interpretable models, such as decision trees or linear regression, which are inherently more transparent than complex models like neural networks. When high accuracy necessitates the use of complex models, techniques such as local interpretable model agnostic explanations and Shapley additive explanations can be employed to provide post hoc explanations. LIME, for instance, generates locally faithful explanations by approximating the model's behavior in the vicinity of a particular prediction with a simpler, interpretable model. Another crucial strategy involves the use of frameworks that embed transparency and explainability into the lifecycle of AI systems. The European Union's General Data Protection Regulation provides a legal framework that mandates transparency in automated decision-making. Compliance with such regulations not only mitigates legal risks but also promotes trust among users. Organizations can adopt the Ethical AI Framework, which emphasizes fairness, accountability, and transparency from the inception of AI projects. This involves regular audits and assessments to ensure algorithms are functioning as intended and are free from biases. In practice, professionals can also utilize visualization tools to enhance understanding of AI models. Tools such as TensorBoard for TensorFlow provide visual insights into model architecture, training processes, and performance metrics. These visualizations can help developers pinpoint areas where models may be overfitting or underperforming, guiding them toward more transparent and explainable outcomes. Additionally, the use of model debugging tools like IBM's AI Fairness 360 and Microsoft's InterpretML allows for the identification and correction of biases, further enhancing transparency. Case studies provide valuable insights into how these strategies can be implemented effectively. A notable example is the use of AI in predictive policing. In some instances, opaque algorithms have led to biased policing practices, disproportionately targeting minority communities. To counteract these issues, police departments have begun employing transparent models and engaging with community stakeholders to validate and improve these systems. By incorporating feedback and making algorithmic processes visible and understandable, these departments have been able to reduce biases and improve community trust. The financial sector also offers illustrative examples. Credit scoring models, which historically have been criticized for lack of transparency, are now being reevaluated with an emphasis on explainability. Firms are increasingly adopting tools like SHAP to provide customers with clear reasons for their credit decisions, which not only complies with regulatory requirements, but also fosters consumer trust and satisfaction. To ensure ongoing transparency and explainability, continuous monitoring and evaluation of AI systems are essential. This involves setting up mechanisms for real-time tracking of model performance and the impact of decisions made by AI systems. Tools like model monitoring by Fiddler Labs provide capabilities for tracking drift in data or model performance, ensuring that models remain transparent and explainable over time. Regular updates and training of staff on emerging tools and techniques are also critical to maintaining a culture of transparency within organizations. Moreover, education and communication play pivotal roles in addressing transparency and explainability risks. Stakeholders, including developers, users, and decision-makers, must be educated about the importance of these concepts and the tools available to achieve them. Workshops, training programs, and collaborative forums can facilitate knowledge sharing and skill development, enabling professionals to effectively implement transparency and explainability measures in their AI projects. In conclusion, algorithmic transparency and explainability are indispensable to mitigating risks in AI model development. By leveraging interpretable models, utilizing tools like LIME and Shape, adhering to ethical frameworks, and employing visualization and monitoring tools, professionals can enhance the transparency and explainability of AI systems. These efforts not only reduce the likelihood of biased or erroneous outcomes, but also promote accountability and trust among users and stakeholders. As AI continues to evolve, ongoing commitment to transparency and explainability will be crucial to ensuring ethical and responsible use of these powerful technologies.